Station Houston on 2. Are you ready for the event?
We are ready for the event.
ESA, this is Mission Control Houston. Please call station for a voice check.
Andre and Don, this is ESA, International Space Station. We are ready for the event. How do you read?
Hi Frank, good to hear your voice, and hello at EAC everybody. We can hear you loud and clear.
And we have a great picture here, Andre and Don. Thank you very much for joining us today. It's wonderful to see you all floating and smiling there in the space station. The first question maybe from my side to all these people here in EAC that were here and they visited our Columbus module and all kinds of things, and a lot of questions in microgravity. Can you demonstrate a little bit to us what it is, microgravity?
Well, actually we can, and Don prepared a great experiment, which we will now demonstrate. I mean, this is all for science, so we really do some science experiment here. So normally we let some things float, etc., but now we're going to really demonstrate some scientific phenomenon.
Okay, we all know that pendulums are a gravity machine and they need gravity to work. And I have an example here of a pendulum where we put a long spring on the end of the pendulum and the spring can replace the effect of gravity. Go ahead, give it a small perturbation. So now this spring is giving a force that is like gravity for small angle displacement. And small angle displacement is where the sine of theta equals theta, and of course that's when theta is measured in radians. And so here we have an example where a pendulum which simply will not work in gravity, you affix a spring to the end of it, and now all of a sudden it will work. And it works according to the pendulum equation where the period is mass independent and it depends on the length of the pendulum. So that's one demonstration here in a weightless environment. But now, let me change the spring just a little bit, and we'll change the behavior of the pendulum. Okay. Now the spring, instead of pulling the pendulum along its length, it's perpendicular to the length, and that. Okay, hold on. Yep. And it's perpendicular to the length, and that changes the dynamics. It's no longer a pendulum with a pendulum equation. It's now a simple harmonic oscillator, and the frequency or the period of vibration is now mass dependent. So this was a simple demonstration. A simple demonstration that shows an apparatus that we're all familiar with on Earth, a pendulum, but it won't work in a weightless environment. You add a spring force to it and it becomes a pendulum again, but then you change the spring angle 90 degrees, and all of a sudden it changes its behavior, so it's a mass-dependent period. It becomes a simple harmonic oscillator.
Well, thank you very much for this very interesting demonstration that you have given for things that only can work in microgravity. And Zan, I think you have the next question for Don.
Sure. First, can I say that was just so cool. And thank you so much for taking the time to speak with us. This is Zahan Barmel from the YouTube team. I have a question in two parts. Part one, can you tell us what is the best thing about working on board the International Space Station? And part two, can you give us some idea of what typical research you carry out on board the ISS?
Well, the best thing is that if you're normally working in science, then you're concentrating on one field. The nice thing of being an astronaut is that you do research in all kinds of fields, and that's a big variation, which is the newest ideas. So that's a nice feeling that you're working. For example, one day you do a biology experiment, the next day there's a combustion experiment. Don did a lot of combustion experiments, for example. Then you are a subject or an operator for a human physiology experiment. Then there is something with Earth observation or even robotics. We have been working with Robonaut. So it's technology, it's life science, it's material science, and that is one of the very nice aspects of being an astronaut, to be in all these different fields. I guess this answers also the second part of the question straight away.
Hello? Hello, my name is Laura Calvo.
Yes, go ahead.
My question is, do plants undergo the same stress as humans do in space?
Plants and humans have significant different physiologies, and the environment on space station is designed for humans. And so plants don't necessarily do very well in this environment. They are under stress, but different kinds of stresses than what human beings have. And it's actually quite challenging to raise a plant in a weightless environment, as I've been working on in some of my off-duty time. Now, you can design a complex piece of equipment which inside of the equipment provides the environment that is conducive for plants to grow. But if you just want plants to grow as the equivalent of a potted plant in a corner of a room, that's a tough thing to have in a spacecraft.
Hello, my name is Maria Vilas, and my question is, how long could an astronaut stay on the ISS and respect a full health recovery back on Earth?
Now, that's a very interesting question. People have been in space for a long time. A Russian doctor, Polyakov, has been in space in one go more than a year, and he was in good shape when he came back. We do a lot of effort to stay in shape, so we do sports every day to keep our muscles and bones in a good condition. Now, of course, there is some deterioration in weightlessness. You still have some muscle atrophy, some bone mineral density loss, and of course there's the radiation. Now, so far all the astronauts get back into normal shape, although it takes a long time. For example, for the bones, it can take a very long time before your bones are back. The effects of radiation are cumulative, so that is something that you cannot turn back, but this is not different than for people who work in certain areas on the ground involving radiation. So in general, with the help of all the medical people on the ground and the sports that we do, also after flight, we do a lot of things to get back in shape. All the astronauts get back in normal shape after the flight.
Hello, my name is Amr Mohammed, and my question is, what do you think about the future of space exploration? I mean, space exploration is very expensive, and with the current economic situations all over the world, I would like to know what's the future of my generation in space exploration.
Good question. First off, space exploration compared to what we spend our money on socially in the form of governments is small. It's a small amount of our social resources that we're currently devoting to space. Now, my generation has forged out the current space program that you see, and of course there was a generation before me that forged their version out. And what the future of space exploration will be for humans and robots is going to depend on you and what your generation decides that you want to do. So one of my favorite quotes is, "The best is yet to be." And that we will see with space exploration, and it will depend on what you and your generation decides that you want to make out of space exploring.
Hello, my name is Marina Lopez, and my question. In microgravity, the human body suffers some changes, but is it known what could happen to a pregnant woman and her baby in the pregnancy at the birth happening in microgravity?
Very interesting question, which I cannot give you the answer straight away because we didn't have such a situation, luckily, because this is a strange environment, and we can not afford to do some kind of an experiment like this, at least with humans. So, because we know from lower vertebrate experiments that have been done that there is an effect of gravity on the development of embryos. So this might be something dangerous, at least at the present time, for humans to try out. So this is something that maybe in the far future this might be an issue that is getting important. But at the moment we don't do this with humans. Although the experiments with animals are very interesting because, like with what we do also with plants, we see it then also in the animal development that there is an effect of gravity on the development of the cells. Now this is interesting because the baby, the embryo itself inside the womb is actually floating. So you can compare it a bit with microgravity in that sense. But apparently even on those cells, gravity has an effect.
Hi, my name is Luis Alvarez, and I wondered if there has been any discovery made in the ISS in microgravity conditions, which we use every day in our normal life.
The benefits of science and technology come slowly and incrementally. And these are endeavors that you work on over long periods of time, and over these long periods of time you will see the benefit come out. And this applies to both science and engineering and technology development on Earth, as well as what we see here in space. And I think the best thing to say about the benefit of exploring space can be from its effect on human beings. To be able to see our planet from a view outside of a planet looking in or looking down, and to be able to understand our place in our solar system and maybe even the universe. And I think this is one of the most outreaching effects of human beings going into space. And I like to sum up the purpose or the value of exploration from a T.S. Eliot quote, where he paraphrases the value of exploration is to be able to go, and when you come back, you know you're home for your first time.
Great, and thank you very much for all these interesting questions. Han, you have another question, I think, for the crew up there.
I have one more question. So one of our goals running Spacelab is to showcase some of the best space and science-related video content on our channel. And so my question for you is, what is your favorite YouTube video?
Well, that's an interesting one because there are so many in all kind of fields. The funny ones, the interesting ones. There's a lot of nice video tubes from video films from Don with all his science experiments. I know very well that one of the first that I liked very much was actually something to do with nature, which was Battle at Kruger, and that was very interesting, which I watched a lot. But nowadays, the choice is so big that it's pretty impossible to mention a special film.
From this question as well, does anybody in the room has a science-related question? Because it's really YouTube and science, and so anybody has a science-related question? Nobody dares to ask a question to the space station. Come on, guys, it's your chance. Okay, science-related question.
Yes, hello, my name is Jaime Costa, and I'd like to ask what can you hear from the ISS, if you can hear something, like some impact, maybe on some sort of vibrations, I don't know.
So yes, a good question related to all the noises that you hear on ISS.
Well, inside station, there's a lot of machinery. There are fans and motors and things like that. So you hear a lot of machinery kind of noises. But what's really amazing is to go in the Columbus module, and it's best to do this when it's crew sleep time, because everything's quiet, the lights are turned out, and you just sort of float in the Columbus module, and you can hear all this groaning and creaking and popping. It sounds like an old wooden sailing ship, maybe what Columbus's ship might have sounded like, and you hear all this groaning and creaking and popping, and you wonder what's making all of that noise. Because, of course, we're surrounded by a near vacuum in space, and acoustical propagation won't go in a vacuum. So what's making that noise? And Andre and I were talking about that. We're not sure, but we think it's a micrometeorite shielding on the outside of Columbus. It's designed a little differently than the rest of the station, and we think that it's groaning and creaking through thermal stress as it undergoes heating and cooling cycles with day and night. But we're not sure about that.
Don and Andre, thank you very much for this very interesting video conference live from space. I think everybody here was excited to see you, was excited to listen to your answers to the interesting question. Can I hear a big cheer from the audience for Don and Andre?
Okay, that was great. Thank you very much. And it was a pleasure. Good luck with all the science.
Station, this is Houston ACR. That concludes the event. Thank you.
We are now returning to our normal comm.